No, we have it.
You thought I was going to put one in my drink. Racist.
Alright, today we are going to take a look at the converse of the Pythagorean theorem. Right? The converse of the Pythagorean theorem lets us determine whether a triangle is right, acute, or obtuse. Okay? So we already know from what we talked about yesterday that if a squared plus b squared equals c squared, then we have a right triangle. But if a squared plus b squared doesn't equal c squared, then we can still get some information from that. If a squared plus b squared, if that sum is bigger than c squared, then my triangle is acute. And if a squared plus b squared is less than c squared, my triangle is obtuse. Now, the way to remember the difference between these two is something that we've already talked about in here. Okay, I think this was in chapter 5, when we talked about the longest side is opposite the largest angle. So, if we have some really long side, right? So here we're saying that c is big. C is bigger than a squared plus b squared. If that's the case, okay, if we have some really long side, two shorter sides, that really long side is going to have to be opposite a really large angle. So if C is really big, then my triangle is obtuse. So if C is bigger than a squared plus b squared, the triangle is obtuse. Otherwise, right, if C squared is less than a squared plus b squared, the triangle would be acute. Right? So in problems like this, we're going to be given all three sides, and we need to determine whether the triangle is right, acute, or obtuse. So in this first example, we've got sides of 20, 10, and 10 times the square root of 3. So A and B, again, are always going to be the two shortest sides, and C is going to be the longest side. So these two sides, the 10 and the 10 times the square root of 3, be my A and B. And between those two, it doesn't matter which one's A or B, just as long as the longest side is C. Okay, so what we want to check, okay, we want to see, is a squared plus b squared, is that equal to c squared? Is that greater than c squared, or is that less than c squared? So when we're setting this up for now, we're going to put a question mark right here, because we don't know if this is going to be an equal sign, a greater than symbol, or a less than symbol yet. Okay? So I'm just going to plug in my values. So A is 10. So we have 10 squared plus 10 times the square root of 3 squared, question mark 20 squared. So now, we can plug these values into the calculator. 10 squared is 100. Now, if you're putting this into the calculator, 10 times the square root of 3, since there's two things there, you need to put it in parentheses when you put it in the calculator. Right? So if we put 10 times the square root of 3 in parentheses, squared, what do we get? We should get 300. Question mark, and then 20 squared is 400. So on my left side of the equation, 100 plus 300 is 400. Less, and we can now fill in our sign, right? Because I see that 400 is going to equal 400. If we get the left side and the right side of the equation to equal each other, my triangle is a right triangle. Right? Questions so far? Let's try another one together here. Let's jump down. And look at let's look at a couple of these here. So if we look at the directions say first, determine whether each set of measures can be the measures of a triangle. How do we determine first if 3 side lengths can even be the lengths of the side of a triangle? This was something we talked about a few chapters ago. So first we need to verify these could even be a triangle before we look at whether that triangle would be acute, right, or obtuse. So how do we do that? How do we determine whether sides of a triangle, or whether 3 sides could be the lengths of the sides of a triangle? Exactly. If the 2 smaller sides add up to be greater than the third side. Okay, so let's do number 2 together here. So on this one, the first thing that we need to do is check to see whether it's even a triangle or not, before we think about whether that triangle is acute, right, or obtuse. So we want to check, do the 2 smaller sides add up to be greater than the third side? Yes, right? 20 plus 30 is greater than 40, or 50 is greater than 40. So yes, this is a triangle. Now let's figure out whether that triangle is acute, right, or obtuse. And to do that, we want to think about a squared plus b squared. Is that greater than, less than, or equal to c squared? So that's where we're going to put the question mark in our Pythagorean theorem here. So my setup then will be 20 squared plus 30 squared, question mark, 40 squared. So we use our calculator. 20 squared is 400. 30 squared is 900. And 40 squared is 1600. So my left side of the equation, 400 plus 900, gets me 1300. And now we can see that 1300 is less than 1600. So I can fill in my symbol now. So what does that mean then? If a squared plus b squared is less than 1600, what kind of triangle do I have? This would be an obtuse triangle. Alright. Yeah, my markers are pretty low.
Did I give you some?
Yeah, these are them. No, they're fine. I use a lot of markers.
I was gonna say,
I
you must be
ordered some
right.
new ones. I'm supposed to
I
get here
might
today.
have some in my basement too.
Thanks. But they should be coming today from Amazon. I'm just gonna get them today.
Don't go with it.
Alright, so
Not follow.
2 steps for a problem like this, right? First, figure out whether we even have a triangle or not. See if the 2 smaller sides add up to be greater than the third side. If we do have a triangle, then we use a squared plus b squared and see if that is less than, equal to, or greater than c squared to determine if the triangle is acute, right, or obtuse. Questions? Then let's take a few minutes and try some of these. With parentheses.
So like 10, second, 3, and then you go arrow, and then parentheses, and then square. That's what it was. Okay, thank you.
Alright, take a look up here at the answers. Okay, it's okay if you don't have all of them done. Right? Take a look up here at the answers. Now I do want to talk about at least one of these ones that has square roots in it. Okay, so let's take a look at number 7. On this one, first, if we want to determine whether it is even a triangle or not, it may make sense to get decimals here. Okay, if I just type the square root of 5 into my calculator, I think we get like 2.2?
Yeah,
Like that.
2.2 and 3.4.
And then square root of 12 is like 3.4. And then square root of 13 is
3.6.
3.6. So if I take 2.2 plus 3.4, that is bigger than 3.6. Okay, so it is a triangle. Then we need to go and determine whether it's a cube, right, or obtuse. So to do that, we're setting up a squared plus b squared and seeing if that is equal to c squared. So I'm going to do that over here. So we'll have the square root of 5 squared plus the square root of 12 squared. And I want to see how that compares to the square root of 13 squared. So this problem is actually really nice because whenever I have a square root and a square, those cancel each other out. So the square root of 5 squared is just 5. The square root of 12 squared is just 12. And the square root of 13 squared is just 13. So here we get 17, and that would be bigger than 13. So that means the triangle would be acute. Okay, if a squared plus b squared is greater than c squared. Okay. Questions?